Welcome back, guys. So in today's session, first we will finish the last session where we were doing the database integration. There were one point that I left that I will cover it, and after that, I will explain about HTTPS in Mule. So how we can make our HTTP API to HTTPS, how we convert actually, and exactly what are the terms are there that we need to understand. Everything that I will explain, and that we will gonna finish in today's and tomorrow's class. Okay, so stay tuned and let me share my screen. Let me share my Anypoint Studio. So moment, I'm just closing other projects. So this was the project that we were working, and there we already configured the database, and there we had done some queries. Okay, so let me open this DB connector. So I have shown you already like how we access the payload, how we set the variables, and how we pass the query in the database connector. So in the last class you we were adding this select query in the database, and we were doing something like this. Okay, so let me save it again and we'll show you exactly to refresh what we were doing the last time. So we did a query we to the database with the help of database connector. Okay, and we use this query parameter, and based on this query parameter we were passing this query parameter, and that query parameter we were using to query to the database. Okay, so now today what I want to show you about the input parameters, how we set input parameters, and after setting that, how we use that parameters into our query. Okay, so one moment, it's initializing the app. It's building 75%. Once it's 100% complete, then we'll hit. Okay, it started. Let me show you again this. Hit it. What happened? There is some error. Sorry. No problem. I will just finish this and redeploy. What error is there? Okay, what is the problem? Let's start from this. This. Let me debug it. So I will show you how to use in parameters, how we declare that, and how we use into our query. That actually why we use it, because when our query is very long, like when we are doing, for example, insert query, right? So in insert query, we need to insert a lot of values. So if we write like plus plus vars dot uh, vars dot variable one, vars dot variable two, vars dot, so it will be, it will be very long query that we need to pass in our database connector. So to avoid that, we declare our in parameters, and that after declaring that, we just use its reference in our query. So it's deployed. I hope so. Okay, it's starting. First, I will show you as it is that we did last time. I don't know why it's showing this error. where's dot query. Query. No. Am I doing something wrong here? Why it's showing this error? Not sure. No problem, we'll check it again. Okay, it's deployed.
And can you please close the flow and reopen the flow once again?
This one? Yes, tell me.
Please open the please close the flow and reopen once again. Maybe
no, it's fine.
due to
Actually,
that
it's deployed, so sometimes it's a studio issue.
okay.
Okay, so
Yes,
it's
yes.
fine now. So let me hit the request. So if you see, we passed the query parameter employee ID 313, and that we were setting into the variable as attributes.query parameter cmp id and default value was 123. So it is as per database. There is 3 for 313. We have 2 records. So if you see the payload in mule debugger, payload size is 2. Okay, so let me finish this flow and we'll see the postman. Okay, so ID is location and this, because we were doing some transformation there only with the first index we were taking. Okay, but it's fine. I think this thing I already explained. Now what I will do, I will change the query in the DB connector. Here, what I will do, I will just remove this one. I don't want to set it here. Instead of that, I will give the input parameter something like UP, just reference. Okay, and this I will add it here. QP. Okay, so how we are passing the query parameter that we were passing like where's.query earlier. So now what we did in input parameters, we just added where's.query with the keyword with the key QP, and that we referred in our query. Okay, so like this we can, you know, we can define so many fields that we want to use in our query. We can define so many input parameters, but it should be like this. I was declaring one, so this one is also fine, but you are if you are declaring only single one, then you can remove these brackets. And if you are doing like if there are number of fields like qp1, qp2, qp3, then you need to use the brackets because it will be kind of a JSON that you need to pass here. Okay, so now we referred it, save this one, saved it. It will redeploy and then we'll see how it works. Okay, so this is like how we define actually our input parameters. But when you have like for example, you have select query like select star from this table where this will be the key and this will be the value. Okay, so I think that time when you defined input parameters, key also in the input parameter and the value also in the input parameter, then I think input parameters will give you some error. So in that case, what you need to do, you need to directly use plus plus the key where stored like whatever sorting key equals to whatever sorting key value. Then I think if you then you cannot directly use this input parameters. Okay, so that you need to remember. For example, employee ID, we have something like for this also QP key, for example, I'm giving. Okay, and I for that we have where stored emp id. Okay, so you want to give this one something like this, then it will not work. It gives an error. Okay, so what you need to do, instead of doing this, then you just directly need to add this some same like in our earlier class. How? Like this complete string plus plus uh, where's dot employee. Okay, this like this, and it is plus plus, and again plus plus. It will be like this. Okay, and then after this it will be plus plus where's dot query, like this. It will work. Okay, and at the end we need to add a single colon. So because, and also here, because value should be in, if it is a string value, that then it will be like in single column, but if it is not a string value, then this we will not add the single columns. Okay, in that case you need to give something like this. But if you have a just, but you don't want, the key should be static and value will be the dynamic, like in our case, so then we don't need to this. Okay, and we just directly pass where employee ID is QP, like this. Let's save. It's already saved, and we'll hit the API. So it will give us the same value like earlier. Hit this API, and you see in Mule Debugger, the payload is 2. Okay, so it means it is accepting whatever query we like, however we are passing the input parameters. So this was very important case that in the last class we did not cover. We kept it on hold for today's class. So this is done now, and whatever transformation we are doing in transformations, it will execute and we'll get the final response. Okay, so database integration is done. I have explained this thing. You can practice more queries, like select whatever we were doing here, like insert query, create table, insert, select, update, delete. Okay, you can try different queries during practice time. And if you face any issues, you can ask. Okay, so let's move to next topic. Today's topic, that is HTTPS in Mule. Okay, so in my first class or second class, where I was explaining about HTTP protocol and HTTPS protocols, so there we covered what is HTTP and what are the HTTPS, right? So HTTPS, it stands for, I am repeating it again in terms of today's topic. So HTTPS stands for Hypertext Transfer Protocol. Okay, but it is also referred to as HTTP secure and HTTP over SSL, and it provides a secure method using some kind of encryption to move the data over the internet. Okay, so for that encryption we use SSL or TLS. Okay, so in HTTPS, like when terms coming like encryption, using encryption, so for that we use like TLS or SSL. So that is also I will explain. Okay, so HTTPS is first came into picture in 1994 when SSL and HTTP were put together. So that time HTTPS came into existence. Okay, and HTTPS relies on encryption technologies that I was telling on second point. So that technologies are SSL or TLS to secure the connections. Okay, so the question comes into mind that these SSL and sorry, the HTTPS website is always secure or it's not secure. So it's like it depends actually. If you see in the browser it's HTTPS, but please look into the URL, whatever you are hitting, that it is correct, whatever you want to hit or not. Okay, so don't just blindly trust if it is a HTTPS. please check URL again, whatever you are hitting, that it is, because sometimes if you see in your WhatsApp messages or Telegrams, you get some link that you feel that it is correct. They do a small change in the URL. Okay, but like for example, you are hitting mulesoft.com, but they will change the spelling of MuleSoft and you will hit, and there can be some scam. Okay, so whenever you hit a URL, please take care of each and every word. Okay, so that is really important. Now the next step is to enable HTTPS in Mule application. We require the understanding of some concepts like SSL, TLS, key store, test store, one-way SSL, two-way SSL. The guys who are preparing for interviews or who are attending the interviews, interviewer generally asks these questions: what is SSL? How you convert your HTTP API to HTTPS in Mule? What is key store? What is trust store? How you do one-way SSL in Mule applications? How you apply two-way SSL in Mule applications? So these are very important uh, things in like in terms of interviews and in our real time projects. So but generally some developers does not get the opportunity, when we really does not get the opportunity to hands on for these type of things, like how to convert HTTP to HTTPS, because it's a one time job. Okay, and a lot of developers, they join in mid of the project. Okay, so they miss that things like a hands-on on this technology, on this concept. So we will do a kind of, I will show you a kind of demo also by creating a two applications where we will use one way SSL and two way SSL. So don't worry, but it's a one time task. Okay, so first we'll cover what is SSL. Okay, so SSL, that like I already explained, like it is no, I think I did not explain. Yeah, so SSL is a short, like it's a full form is secure socket layer, and SSL certificates will give you a way of encrypting. Okay, when we talk about HTTPS, so we use SSL for encrypting the data or encrypting the information when it travels over the internet. Okay, so this is particularly important as it ensures that data in transit cannot be intercepted by those with malicious intent like hackers. Okay, so it is very important in those, in that way. Okay, so first I will explain like uh, I think something is I missed. Okay, yeah. So who needs these SSL on their website first? Okay, so if you sell the products like any online services, or you take some personal from people, then you absolutely need an SSL certificates. Even if you don't having an SSL certificates, you can certificates. If you don't have any SSL certificates, or you don't know, there are some online websites who provide SSL certificates. Okay, so those who work or process legal or medical data. Okay, if you take payments or financial data online, so these kind of things really need SSL. Okay, and there are some some web developers need SSL certificate for their own websites when they create. So there are a lot of uh, companies who provides the SSL certificates. Okay, so first question people ask, like, what is the difference between SSL and HTTPS? So HTTPS is a combination of HTTP with either SSL or TLS. Okay, so it provides encrypted communication and secure ID of a web server. And SSL is simply a protocol that enables secure communications online. It was originally introduced in 1994, and there are three versions like SSL 1.0. Due to security flaw, SSL 1 was not released. SSL 2 and SSL 3. Latest is SSL 3. Okay, so this was all about SSL, and there is now TLS. So developers generally get confused between SSL and TLS, but TLS means transport layer security, and SSL is our secure socket layer. So both are almost same. Okay, but TLS is like more secure version of SSL. But if you ask like difference or moreover, like both are same. Just TLS is the extended version. It's extended version of SSL. Okay, so TLS also have these versions. 1.3 is the latest one that we use. Uh, um, the latest version is 1.3, like SSL latest version is 3.0. Okay, so we go to next one. This is a side-by-side comparison of TLS, SSL, and HTTPS. So this is SSL, the first cryptographic protocol developed in 1995. TLS, the successor of SSL, that is more secure, and HTTPS, the secure version of HTTP. These are the versions, and use SSL no longer is used, and TLS currently used, but 1.0 and 1.1 to be deprecated in early like 2020. That is already deprecated. HTTPS browsers mark sites that don't use HTTPS as not secure. Okay, so if you enter some websites like https.mulesoft.com, so HTTPS means it's a secure website. Okay, if there is only HTTP means it's not secure one. Mm, got it. So these are some explanations about HTTP, TLS, and HTTPS, TLS, and SSL. So in a nutshell, SSL is obsolete, and TLS is the new name of older SSL protocol. Uh, it's a new name of older SSL protocol as modern encryption standards using by everybody. So technically TLS is more accurate, but everyone knows SSL. Okay, so there are some considerations of TLS protocol. I will explain that. Like it prevents hackers from tampering the communication passes between the server and user. It also prevents hackers from listening to server communications. So TLS adds latency to site traffic. So with addition to HTTP, uh, with addition of HTTPS, TLS makes connection faster. So at last, one question comes like, do you need a SSL TLS certificate or not? So if you look at SSL versus TLS certificates, both perform the same task of encrypting data exchange. TLS was an update and secure version of SSL. So nevertheless, SSL certificates that are abundantly available on the internet serve the same purpose of securing your website. In fact, they both offer websites the same HTTPS address bar that have come to recognize as hallmark symbol of online security. So it was all about your website security. Okay, so these things are really important. Okay, so let's move to the next topic, that is key store and trust store. So when you convert your HTTP API to HTTPS, so these are also important terms like what do you say, yeah, TLS and sorry, key store and trust store. So in an SSL handshake, the work of trust store is to verify. No, first I will explain the definition of this key store. So key store is a server-side asset that stores the private keys and the certificates with their public and private keys. So I repeat it again, key store is a server-side asset that store the private keys and the certificates. So it's a server-side asset and store private keys and certificates. Okay, with their public and private keys. So this is like in short, very important definition that explains everything about the key store. In the same way, trust store. Trust store is a client side asset that serves as a repository of certificates that the client should trust. So this is very short definition, but very valuable one. Okay, so in an SSL handshake, or when you create a HTTPS, when you create an API with HTTPS protocol, so the work of trust store is to verify the credentials, where the work of key store is to provide those credentials. Okay, so these are more important differences between trust store and key stores. But not only the one, because when there is Java, when you use Java, so these differences vary, but I don't want to keep you in those things because it will get confused. It means it will confuse you. Okay. So first, like Keystone Trust Store is this, and when we already talk about SSL. So there is two type of handshaking, like one-way SSL and two-way SSL. So one-way SSL it means validation only at client side. We do not we don't do any validation at server side in one-way SSL. So if you see this diagram, that is clearly showing you like what is like how the one-way SSL works. Okay, so I think I want to explain you one more thing here. It slipped from my mind. Okay, no issues, will come again. So let's understand about one-way SSL. So here the client is this client and this is the server. So client makes an HTTPS call to access server resource. So if you see this one point, it calls, it makes an HTTPS request, HTTPS call to access server resource. Okay, so this server is configured with the key store, and it retrieve its certificate from the key store. Okay, so if you go back to key store, if you see, it stores private keys and certificates. So in the same way here, server is configured with the key store and it retrieves its certificate from the key store. Okay, so I think that makes sense. Whatever definitions for Keystone Trust Store I have written, so I will explain that way only. So this diagram similar to that. Okay, so server sends its certificate. When it gets the certificate, it will send the certificates to the client. Server sends its certificate, that is in the second point. So it will send its certificate to the client. So client uses its trust store. This is the trust store that client will use to verify its server's certificate. So if you go back to the trust store definition, it is a client side asset, and that serves as a repository of certificates. Repository of certificates, whatever certificate sent by server, it will verifies that it is correct or not. Okay, so I think it's now it's in sync, and I hope everybody is understanding. So server certificate has public key of the server along with other information. Okay, so I repeat it again. Server certificate has a public key. A server certificate that sent to client, it is having a public key of the server along with other informations. So client generates a session key. Client generates a session key, some unique random keys. Okay, it will generate a session key. It will generate a session key. So client encrypts this session key with the public key of server that is sent by a server. Okay, so server certificate, so client encrypts the session key with the public key of server and sends this encrypted session key to the server. So first it sends the certificate, it will validate, and then it will trust that server certificate, and then it will encrypt. It will send a session key that will be encrypted with the server's public key. So I hope everybody is seeing, because it's a really complex thing, but very easy. That's why I took this diagram. Okay, so server gets this encrypted session key that client created. Okay, with the public key of server and with the public key of server. So it decrypts this key using its private key. So there were a private key. Okay, there were a private key. It will decrypt that session key. It will decrypt that session key using its private key. So both client and server has the same session key now. Okay, they both have same session key with them. So during SSL handshake process, the certificate is presented, verified, and session key is negotiated. Got it? So only session key is getting negotiated. So in this way, we are exchanging the data between client and server. And there we are using a session key that is negotiated. So after SSL handshake, the communication between client server is means the client sends the data to server by encrypting the data with the session key. Server decrypts the data using the same session key. In the same way, when server needs to send the data to client, it encrypts the data with the same session key. After this whole process, I'm repeating. So I'm repeating it again after SSL handshake, because SSL handshake is done. The client sent the session key and server used decrypted that session key with its private key. So after that, if client sends the data to server, client sends the data to server by encrypting this data with the session key that it's created, and server decrypts the data using the same session key. In the same way, when server needs to send data to client, it encrypts the data with the same session key that's sent by client. Okay, and client receive the encrypted data and decrypt it using the same session key. So both have the same key now. Okay, and both now can easily transfer the data. So now let's talk about the checking the identity of client and server. Now we done the SSL handshake successfully. Now let's talk about the checking the identity of client and server. So in one way SSL, client checks the identity of the server, and there is encrypted communication between client and server. So client's identity is not checked by server. Here, client's identity is not checked by the server. Any client can communicate with the server after verifying the identity of the server. Okay, so but sometimes the requirement is to verify client also. Here we were verifying the server, but sometimes we need to verify the client also. Okay, so in such cases, what we need to do? We need to use the two-way SSL, because in one-way SSL, we were just verifying the server identity. But now we want to verify the client's identity also. So only one identity, that was one-way SSL, but now we want to both. So it means it is a two-way SSL. Okay, so that is now come to two-way SSL. Guys, can you mute yourself? Yeah. So in two-way SSL. So in two-way SSL, the identities of both client and server are verified. If you see this diagram, I will explain this. So both server and client have its own key store and trust store. Here also we have key store. Server side also we have key store and trust store. Client side also we have key store and trust store. So both server and client have its own key store and trust store. So client is configured with the key store to access its keys, certificates, and trust store to verify server certificates. So whatever server will send the server, it will verify by trust store. So if you go back here, it's the same one. Key store, trust store, send the certificate, verified using the trust store, and same will happening here. And reverse process, because of now we are talking about the reverse process also. So that's why server is also using a trust store. Earlier it was only the key store, but this time in 2 SSL, server is also having a trust store. So it's opposite. If you see diagram again, trust store, client side we have trust store, server side we have key store. But now we have here key store and here we have trust store. So two additions, trust store at the server side, key store at the client side. So client server is also configured, means both are configured now, means with the key store and trust store. So client makes an HTTPS call again to this to access server resource. I'm explaining the two-way SSL. So to explain that again, in the same way like one-way SSL, the client was sending a request to the server over HTTPS. In the same way, we will send a request to server over HTTPS. So server receives the client request, retrieves server's certificate from key store and send to the client. So server sends its certificate, client check if it does server certificate, means it checks its certificate with the help of trust store. Okay, so clients gets the server certificate and verifies the certificate with the help of client trust store. After verification, client retrieves its own certificate from client key store and sends it to the server. So client verified the server certificate. Now it will get its own certificate. Okay, and it will send to the server. So server receives client certificate and verify this certificate with the help of its server trust store. with the help of this trust wallet that is at the server side. Okay, so both will validate like this their own certificates. So once verified, client generate a session key. Okay, so if you see 1, 2, 3, 4, 5, and then once it is trusted, then client sends session key. It's the same process now. Okay, so after server receives the client certificate and verifies the certificate, then once verification is done, client generates a session key like in the one-way SSL and encrypt this session key with using server's public key retrieved from the server certificate and send the encrypted session key to the server. Server receives it. Server receives this encrypted session key and server decrypts this session key using server's private key. It's the same step that we were doing in the one-way SSL. Okay. So after this SSL handshake, whenever data is exchanged between client and server, data is encrypted by this session key from one side and decrypted using the same key at another side, either this or here. Okay, so one moment. Okay, so in this case, both client and server are verifying the certificate and authenticating each other. Got it? So in one way and two-way SSL handshake is done using public private key pair and session key is negotiated. So then session key, that is kind of semantic encryption, is always used for further encryption and this decryption of the data between client and the server. So this was all about one-way SSL, two-way SSL, and these are the diagrams that whatever PPT I am using, I will upload it somewhere so you guys can understand these diagrams again. And if you have any queries, then let me know. But once I will show you a demo, then it will be more clear to you. Okay. Now, thing is how we generate these keys and certificates. Okay. So we will generate during our demo, we will generate private keys and self-signed certificates. And then we will import these certificates in the trust store. But for that, we need first we need to install the JDK that we already done because we use a tool. There are many tools to create the certificates, but we will use JDK here. Okay, so and we use a key tool. That key tool is that is available in our binary of JDK. Okay, so it is a utility. Key tool will be a utility to manage our key and certificates, and there are many key tool commands that we will use. Okay, so in our demo, I will show you how we generate, how we will create those certificates, how we will import test store. But before that, I think I just want to explain one more thing. Like I was talking about the encryption. So encryption, what is encryption here? Encryption makes the data cryptic using algorithm. Okay, the encrypted data is unreadable to any unintended user, means to any hackers if they don't have the key to decrypt this data. Okay, so and there is also two types of encryption: semantic encryption and asymmetric encryptions. So I'm going a little bit deeper inside, so maybe it will confuse you, but you can watch the video that we are recording. You can watch it again and you will easily able to understand. Okay, so there are two types of encryption: symmetric encryption and asymmetric encryption. So symmetric encryption is client application has to send sensitive data to server application. So client encrypts the data using a specific key and sends the data to server application. Okay, so like I will open this. Yeah, so it will send client sending encrypted data to our server where it will decrypt it. Okay, so during the travel, the data is encrypted and it is decrypted only by the server. So when it is in travel, if any hacker wants, if they will have the decryption, like the key to decrypt it, then only they can get the data that we are passing over the internet. Okay, so anyone who has access to the key can decrypt it. Okay, so many different encryption algorithms are available to encrypt the data. There are many different algorithms are available like AES, Blowfish, 3DES, DES. Okay, so what I feel in every project, there are some, different requirements, like which algorithm we need to use to encrypt the data. Like some use AES, some use Blowfish. Okay, or some use DES, 3DES. There are different encryption algorithms that you can use. And so this was all about symmetric, and now asymmetric. So symmetric encryption, single key is used on both sides. But in asymmetric encryption, we have a pair of two keys, public key and the private key. So guys, it's very important. In symmetric encryption, we had a single key that is used on both sides. But in asymmetric encryption, we have a pair of two keys, a public key and a private key. So the owner keeps the private key as a secret to itself and shares the public key with others. So data is exchanged between client and server, which is decrypted using public or private key pair. Okay, so this is like, for example, server has a public and private key. The server shares the public key with the client, and client encrypts the data using the public key and send it to the server. So server uses its private key to decrypt the received data. I repeat it again. Server shares the public key. I'm talking about the asymmetric encryption. So here I'm taking the example where server has a public key and a private key, and server shares the public key with the client. Client encrypts the data using that public key and send it back to the server. And server uses its private key, because server were having public and private key. Public key sent to the client, but private key is already there. Okay, so server uses its private key to decrypt the received data from the client. So when server sends the data back to the client, it encrypts the data using its private key. It's using its private key now. So it's done. The client sent with the encrypted the data with the public key, and it decrypted with using a private key. So now next time when server sends the data back to the client, so it will encrypt. Now this time it will encrypt the data using its private key and send it across. And client will decrypt by using its public key. Okay, so this is kind of private public key pair works. Okay, and sometimes we use this public and private key pair for signing or verifying the signatures. That is also a different concept. So and sometimes the encryption and decryption they use like there is other thing is like data integrating using hash. So data integrity is I'm going more deeper mode now. So data integrity is important when data is exchanged between two applications. When client and server exchange the data must not be compromised. So data should received by each side without errors. So if I take an example where client wants to send some status, so they like some check, we are paying a check, for example, we are paying a check into bank, and where the client wants to send like check cancelled to the server. Okay, I'm just taking a small example. I don't know it fits. It is correct like in the way of explaining, but uh, uh, I will little bit modify it. So client wants to send the data like check cancelled to the server. So client encrypts the data using server's public key and send it to server. So server decrypts the data using its private key and exchange is successful. Okay. So now here we want to explore the failure scenario. So client is sending order status, for example, like check status is cancelled. Okay. So in between this data transformation and all, a application a different application hacks the communication and sends check status as approved to server. Okay, so between these two, between client and server, there is an application that hacks the communication and sends the check status as approved. Instead of cancel, it is sending as approved to the server. So that application has also encrypted this, means has also encrypted this data using server's public key. Okay, so now server receives the incorrect information because some another application like from the hacker, it hacked the communication. So server receives the incorrect information. Instead of check status cancelled, it's getting check status approved. Okay, and when server means server is receiving incorrect information, decrypts using its private key and use it. This is the data integrity issue. Okay, because it is having everything and it's um, it is sending check status approved, and when server use its private key and decrypt it, and then whatever information sends through this hacking application, it will accept it, and because it's decrypted successfully with its private key, so what server will understand, okay, everything is fine, and it will update wherever server will update. Okay, so it server is getting wrong information, so that is the data integrity issue. Okay, so so how how the data integrity is ensured. Okay, so data integrity is ensured using like the hash of the data which is exchanged between the client and server. So hash is created from the data, a check status cancelled. The input of this hash function is originally like check status cancel, and output is irreversible fixed length digest. Like one way digest is created. This digest cannot be used to create the input data, and the simple change in data will create in a new digest. Okay, so first encrypted data, then digested, and then encrypted data, and then digest, and then complete digest. Okay, so I think I will not go more into deep because it will confuse you guys more. But when we will create our certificates and all, then you will understand in a more clear way. So instead of explaining more, I think I should move now to, how to create a key store and test store. So let's get our hands dirty into that. Okay, so first what we need to do, we will use the key tool that comes with Java. We will use the key tool here. If you have the key tool in your system, means if you have a Java in your system, so the key tool will be already there. So we will create a temporary directory somewhere in our drive, and then we will open a command window and we'll navigate to the directory and execute some commands. Okay, let me open a folder somewhere. Guys, this is very important topic and there are a lot to explain. So I can explain like 2 more hours, but there is no use because once we will do a demo, then only it will more clear. Okay, so I created a folder with name SSL. Okay, let me open the command window here. One moment. One moment, guys. Let me open the command window again. Okay, so it opened this. This is the command window under this directory, under the D folder we have SSL. Okay, so now there are some commands and that I will execute. And I will keep those commands into the repository, and from there you can take all those commands and you can try in your system. Okay, so there is command key tool hyphen gen key space hyphen alias space mule. You can say mule. It's a alias. Alias name means like some name we need to give. So let me understand. I will explain you that
Gen
also.
key.
Yeah, I know the command. I want to explain this key tool, gen key, everything. So it will be more easy to you guys. One moment. One moment. I'm just want to explain some things. Okay. So I'm using this key tool, whatever key I will use. So there is, for example, there will be key store. So name of the key store from where we want to retrieve the certificate. There will be a store pass. Let me add the complete command first for you. Okay, 1 second. One moment. So I will take alias. I'm taking like mule and then the algorithm. We need to use an algorithm. I will use RSA and then key store will be the key store name key store dot jks. Okay. So once I will execute this command, it will ask something I did wrong. Key tool hyphen gen key hyphen alias mule key algorithm. Okay, that is the mistake. This one. Okay, it will ask you about it will ask to enter any password. Okay, because when we create a key store, it will ask you a password, but what is the meaning of that password and all? So here we are giving a key store. So what is the meaning of this key store? So key store means the name of the key store where we want to retrieve the certificate. Okay, and alias means the name of the key store entry. Okay, so this is kind of small explanation. So you can give any any password here. Like I can give any password, for example, here key store password. I'm giving like key store pass. It will not show you, but I just enter. It will enter key store password, re-enter new password. Let me store again. AEYSTOREPASS. Okay, so this is done. Now it will ask you some important informations here, like what is the company name, what is your location, everything it will ask about that. Okay, so because certificate here, we are creating a certificate. Okay, so there it will ask you some things like owner, signature, like who has signed the certificate. So many things are there in the certificate. So let's go one by one. What is your first name? I'm just giving like MuleSoft station. enter what is your organization unit. So like this, one by one, read everything when you create, because in some, because I'm creating just a demo. So I'm giving any name, anything. Okay. But in each organization have some set of rules to create the key store. Okay. So follow that. Okay. And reach each option very carefully. So now, or you can, because I'm just giving, but we can make leave it as a blank. So just go to the next, like next organization. I don't want to pause. Just go next. Okay, just go next. But these are the options that you will get, and you need to give all the informations. Okay, so next. Um, So is CNOUOL alone correct? Okay, yes, it's correct. What happened? I think I'm missing something. Is MuleSoft
Need to pass
session?
while.
Oh, sorry. Yes. Okay, so enter key password for Mule, key store password. So I think I gave whatever password you gave on during this one, enter key store password. It will ask you the key password now. Okay, so first it asks you key store password. Now it will ask you key password. So I'm giving the same here. Estorepass. Re-enter. Keystorepass. Okay, so if you see, it created this keystore.jks file. Okay, so you can use any password. Feel free to use any different password or based on your organization. So I just use the same password, like same password like keystore pass, like name says keystore password, to make to make some simplicity. Okay, so now we created the certificate. Now next process is export the certificate. So the process above, this process here above that here, it creates means key store as well as a certificate. Okay, so now we have to export the certificate so that it can be added to the trust store as the trusted certificate. Let me execute another command. What was that? Key tool, because we want to export. So we'll use export alias new space file 9.cert and key store space key store.jks. Okay, key tool hyphen export hyphen alias. I'm giving mule file. I'm giving like client.cert and certificate keystore.js keystore. So just enter. Java lang exception keystore file does not exist keystore.js. Oh, sorry, my bad. I think the name I gave keys as t is missed. So if you see here, I created the JKS file keystore. The T is missed. So that's why we are getting the error key store file does not exist. Okay, so that's why I changed it key store now. So let me enter it again. Now enter key store password. And the password was EYSTOREPASS. Okay, so now we created this client certificate. So we created the client certificate here. So the third step is import the certificate to the trust store. So we created the certificate. Now we want to import it into the trust store. We exported the certificate and now we are importing the certificate to the trust store. So now We need to run another command after creation of the certificate, that is client.cer that we created here. Okay, we will populate our test store with it. So let's create test store, and for that key command is key tool space import 1v hyphen trust space alias spellings. Okay, fine. Mule space file client.cer space minus key store trust.ts. So we are importing the certificate client CER to the key store. So spelling is wrong. And we are creating a separate file that is the store.ts. Okay. So key tool import. Okay, that is also a mistake. We don't do. There will be no gap, no space. Import -v minus test store. Okay, everything is fine now. Enter.
Key tool.
Oh, sorry. Actually, my keyboard is E and T is not properly working. So enter this. So after this, key tool help. Is there any mistake? Legal option minus test store. Minus key store and trust store.ts. What is the wrong here? Key tool hyphen import hyphen v hyphen. Oh, sorry. I did this wrong. It will be trust. It will be trust CA certs. Now enter keystore password. That was enter the keystore password KEYSTOREPASS. Again KEYSTOR. Okay. So at the end it will ask you trust this certificate. So I will say yes. So we get trust.ts. This is the key store. This is the trust store. So everything is done. So we are done with creation of our key store and trust store. So now we can move to the next step. That is, we will create a simple mule project, and there we will do HTTP configuration. Okay. So what is the time? I think it's already 9 o'clock. So I think I will cover it tomorrow because I need to explain with the demo like one way and two way. So it will take time. So I will cover in tomorrow's class because I need to show you a demo of one way SSL and two way SSL. Okay, so let's do it tomorrow. But today you understood how we create a trust store and key store. So I will wrap up this class now and we'll see you tomorrow again.